Hey everybody, my name's Eric Liu and I'm a junior at Salem High School. Today, in this video, I will be showing the Tetrix vision robot, which I have named the EduBot. I have named it the EduBot because Tetrix is one of the most widely used building systems. With PRIZM, it can be used for general STEM educational purposes. It can also be extended for more advanced robotics learning, such as vision, which I have developed in this project and will explain further in this video. I'd like to thank PITSCO for sponsoring me in this project. Also, I would like to thank Lawrence Tech University Professor CJ Chung, who is also the founder and director of Robofest, for supporting me in this project as well. Here you can see I have the EduBot. The EduBot is made from the Tetrix Max building kit. Some overall considerations I had while building this robot is to have a flat platform at the top to hold the laptop, much like the L2 developed by Professor CJ Chung. I also have a supporting beam here which holds the camera. It's also adjustable so that it can be used for different projects depending on your needs. I wanted also the robot to have good maneuverability, which I accomplished by having the Omni wheels in the back for good rotational movement. Not only that, but I also wanted the robot to be well under control, which I did with the gear ratios. This allowed for good control of the robot at lower speeds. Not only that, but I also wanted easier access to the switch, the controller, and the battery so that it'll be easier to manipulate the robot to my needs. So if I ever wanted to stop a program or turn the robot on or change the battery. I also wanted this robot to be sturdier and more reliable so that it could withstand the weight of the laptop and the battery. The wires and cables are also neatly tucked away from the gears and the moving parts to avoid them from being jammed up. As you can see, here I have a PRIZM controller mounted. The PRIZM is a programmable controller from PITSCO, which enables autonomous control of robots constructed from Tetrix building elements. Hardware features of the PRIZM includes 2 DC motor ports, along with two encoder ports for those motors. There are sensor ports over here, as well as an I2C port. There are 6 servo motor ports, 2 continuous rotational ports, an expansion motor port, a USB controller port, and a battery port here, which gives it the 12 volts that it needs for the power. There are also 2 buttons, the start and stop button. PRIZM is programmable using the Arduino IDE, which makes it an excellent learning tool. Next, I'll be applying the EduBot in the 2017 Robofest Vision-Centric Challenge. For this application, I was able to establish communication between Python and the PRIZM controller. In this challenge, I will control the Tetrix motors using Python and OpenCV, which will be running on the laptop. So just a brief overview of the rules of the challenge. The robot will follow around the edge of the mat and then count the number of target colors there are. And then once it sees the end color, it will stop, spin, and display the correct number of target colors that it saw. First, I'll start the program on the PRIZM controller. Next, I'll start the program on the Python side. I put the target color that I want in front of the camera and lock it in by starting the program. Now that I have locked in blue as my target color, as my robot follows the edge of the mat, when it comes across a blue colored paper, it will add 1 to the target color count. The robot will keep following the edge of the mat until it comes across a predefined end color. As you can see here, it saw red, my predefined end color. It spins, and then it displays the number of blue papers that it saw. In our case, 2. In this next demo, I'll be showing that the PRIZM can also communicate with the C# and EmguCV. I'll be doing this by doing a simple follow the line program following this white line here based on image processing done by C# and EmguCV. So I'll start the controller, start the program. And so when the program starts running, you can see that the white line in the middle here will show up as white, and the surrounding colors will all be counted as black pixels, and the robot will follow the line accordingly.